As Danny introduced me.
I didn't introduce yourself.
My name is Stefan. Je m'appelle Stéphane. But we'll keep it all in English. I've noticed that not much has changed since the Fellows program. Since I've been in, it's still a majority of French. The rest is that everyone's spread out. So my name is Stefan Gross. Right now I'm a security researcher at Panorays with Demi. It's here in Tel Aviv. And then before this, I worked as a security analyst. Well, before this, I was with ITC. And then before that, I was a security analyst at a company in Florida called Team Camry. And yeah, that's about the most I really need to know about me. Everything else we can talk about later. So, what's the Darknet? Most of the time, you'll probably get an answer something like this. It's that shadowy place. You never go there. Stay away from it. But in reality, the Darknet is just an overlay network. It's a network that sits on top of the internet. You can think of it sort of like a virtual network to some extent. Uses the internet as its backbone. And it's only accessible through special software configurations and programs. It's not something that you just turn on your computer and you're on. You have to go download a few things and get going. But it exists, it's out there. And unofficially, the Darknet really refers to Tor and I2P. There's some other networks out there that exist that are similar to these two, but if you ever hear people really talk about the Darknet, they're going to be talking about Tor and to a lesser extent I2P. I2P is the Invisible Internet Project. So we're going to focus on Tor for this talk since it's the most popular, it's the most common, it's the one that you will really hear about the most if you go out and do anything with it. I'm going to make it. It's going to be a mixture of a technical talk. We're going to get into details and like how it works, and then we'll also do a bit of some examples of what you can find on it, the underground economy, what that is, and maybe some live examples if we have time, if we're lucky. And thank you guys for being here so late with me. I appreciate it. I know you guys have long days, and I heard you have an exam coming up. Is this true?
Yeah.
So good luck. Yeah. So, overview, Tor was created by the US Naval Research Laboratory. It was to be able to do research on the internet, like anonymously, ideally, without people knowing the IP address that's going to the websites and doing the searching. It stands for the Onion Router, and in its most basic definition, it's just a network of proxies. So is everyone familiar with what a proxy is? Yeah. If anyone not familiar, raise your hand. So proxy is basically a system that you send a request. If I want to go to Google, I'll send my request to the proxy and say I want to communicate with Google. The proxy will take the request and send it to Google for me, and it's going to make it look like it's coming from its IP address instead of my own. And so Tor really is a network of proxies. It's more technical than just that, but that's the basic overview of it. And it can be used to help you hide your identity on the internet. It's not an end-all, be-all that if you use Tor, you're safe. You have to use it correctly. You have to do some other things if you really want to be as anonymous as possible. And what that means for our sakes, it means that it basically hides your IP address so people don't know that when you're hitting Facebook that it's really you that's hitting it because it's going to show up as a different IP. And we'll get into how it works. So this part is the basic. This is a client, someone you on your computer, you want to go use Tor to go access Google, Facebook, whatever it is. And I'll get into the difference between that and something called hidden services later, and what those are and the difference and how it all works. So for this, Alice, in our case, if you've done the networking portion, you'll notice that Alice and Bob and Jane are used a lot as the example names. But so Alice is going to get a list of Tor nodes from what's called a directory server. And a Tor node is just a server that anyone can run. I can run a Tor node on my laptop as long as you have internet access and a system. You can basically run it as a Tor node. So that means someone can use you to get through and access Tor. If you guys get cold, let me know. I'll turn it off. And yeah, so the first thing Alice does, get the list of Tor nodes, can be just any server sitting on the internet, basically as long as someone is running the Tor server software. From there, Alice needs to create a circuit. And a circuit consists of 3 Tor nodes. You're going to have your guard node, your relay node, and your exit node. It's basically the order in which you'll be jumping through the nodes. So like your guard is also known as your entrance node. It's the first node you hit in Tor to be able to access the rest. The relay just relays between the guard and the exit will actually send it out to your final destination. If you guys have questions along the way, feel free to raise your hands. I'll answer, but as I can, or I'll tell you to save it for later, depending on if I'll cover it later or not. So all the circuits are just initiated as soon as you start the Tor client, and each circuit is going to be used for about a period of 10 minutes until your system will automatically refresh for a new circuit. It can be configured to be a lesser amount of time or to create new circuits often. And once you start going through a circuit, if I start a Tor, I go to Google, I'm going to communicate with Google strictly through that one circuit, strictly through those 3 systems that I'm using on Tor. And the reason being, if you start using different circuits a lot to get to the same place, there are network correlation attacks that people can do, and with enough data they can actually end up de-anonymizing you and figuring out that it's you that's actually accessing all these different circuits. So it's best that, the way they figured it is best, to keep it, once you start connecting to one site, through one circuit, you stick with that site through that circuit for the time being. Okay, so each packet sent through Tor is going to be encrypted in 3 different layers. Have you guys done public and private key cryptography yet? Yeah. Good, this makes it ties in well then. So it's going to be using public and private key cryptography for this. It's going to be using the public keys of the Tor nodes themselves in order to encrypt the data going through. The exit node is your only node that's going to actually see the final data that you're sending out to whatever your destination site is, whatever destination computer is. All the other nodes just see encrypted data. If you're using HTTPS or some type of encryption in your final data, then the exit node doesn't actually see what's in there, it just sees encrypted data. But if it's clear text data, then the exit node can easily sniff and see whatever you're sending through. And so the process, you'll have your final data. You're going to encrypt it with your exit node's public key. You'll have the IP address of the, from here, you'll have the IP address of the, whatever your final destination is inside of this as well, so the exit node knows where to send it. You're then going to take all that, encrypt it with your relay node's public key. You'll have the exit node's IP address inside of here. You'll then take that, encrypt it with your guard node's public key. Also, IP address of your relay node, so it knows where to talk to. And in the end, that's why it's called the onion router. Because if you look at it, it kind of looks like an onion. You have to keep peeling away layers to get in and out of the set. So on the opposite side, once you've done all your encryption, you're sending it out, your guard node's going to get it. It's going to decrypt its layer, forward it off to the relay node. Relay node's going to decrypt its layer, forward it off to the exit node. Exit node will decrypt its layer, send its final data to whatever your destination is. And that will be that. So that's like the basics of how Tor works on a simple connection client going through Tor, going to any normal website. But the Darknet and the underground economy really thrive off of what's called hidden services. And these are sites and can be any type of network service, SSH, FTP, whatever. And these are accessible only through the Tor network. We can get to Google through regular internet, through Tor, whatever you want, but these are accessible only through Tor. And all the names, all the domains, all the sites are only with .onion as a domain name. And .onion sites can't be actually resolved through regular, let's see if I can get this over there. Maybe not. Hold on. But .onion domains can actually be resolved through, actually I'll do a valid one real quick to make it legitimate. Take this one. So, if you're not familiar, dig is a command that you can use to do DNS resolution. So if you want to get the IP address of something or do some other checks, it's pretty easy. And then this will give us an NX domain as a response here. which is basically means it can't find what the domain is. And this will always happen if you try and resolve the hidden service through the regular internet. It won't happen.
These like a ping?
I'm sorry? No, you're sending a DNS request to a DNS server.
Right.
And so
Repeat the question.
Yes.
Repeat the question.
Sorry. He asked if dig is like ping. But it's not like a ping, it's you're sending a DNS request, so you're going to send your request to a DNS server, say, have you guys gone over DNS?
Yeah.
Okay, so as you know, you send your request saying, hey, this is the domain I want to know its IP address. It'll respond back, whether it has the IP address or not. It has the whole, everything going around in the background, but yeah, basically it will come back for any .onion domain. It'll just tell you that NX domain, can't find it. So, all of these sites, all the hidden services, they're 16 characters long, followed by .onion. This is an issue because basically it means if someone can see some of your traffic, they can see something, something, something .onion. They already know automatically it's a Tor site. And if you're trying to be private, it can be a bit of an issue. But so they're looking to change that 16 character limit to be something longer, so that way it's not so obvious that once you see .onion, you just go backwards 16 characters, and there you go, you have the site. And then, sorry, using, going through Tor regularly, going your client to Google or so on, whatever it is, you're hiding your IP address from Google. But you know Google's IP. With hidden services, you're hiding your IP address from that endpoint server. The endpoint server also hides its IP address from you. You don't know where you're getting to in the end. You don't know what server you're hitting. You just know you're going to whatever this address is, and somewhere on the internet it exists, and you're getting there and you're communicating with it. Cool. Yes.
Can my ISP know that I'm sending traffic through Tor?
There are ways. So the question was, can my ISP know if I'm sending traffic through Tor? There are ways to know if you are. The list of Tor nodes are it's easy to get what the IP addresses of the Tor nodes are. So they can do some checking of IP addressing to see if you're communicating with one. By default, the Tor nodes use like standard default ports for Tor. And so they can sort of try and correlate, you're hitting a Tor IP on the standard port that's used for Tor. Excuse me. And so most likely you're using Tor. They can also, if they're really checking the data, they can look at some of the packet data that's going through. Because it uses public-private key cryptography, you'll sometimes see the what would be the addresses of the Tor nodes, sort of like the domain names from their certificates. You'll see it inside of the traffic. Even though the rest of the data is encrypted, like that, you can still get out of it. So it's possible to tell if someone's using Tor or not. It's also a bit of guesswork. Like you can't say sometimes 100% they're using it without doing a bit more checking. But it's you can be pretty fairly sure that based on certain things, someone's using it. So this process with hidden services is more complicated since there's two sides involved. You're going to have your hidden service server that someone's going to set up, so in this case Bob, and he's going to create his hidden service and he's going to want to advertise it. So what he does is he first picks introduction points to help keep himself anonymous, so not everyone knows where his server is actually sitting, what his IP address is. He picks a few systems, they're random Tor nodes, creates a circuit, so creates that whole 3-step hop to those, so they don't know his actual IP address either. And basically tells them, I'm going to have a hidden service. If someone contacts you to speak with me, send it through this circuit back to me. And then, along with that, Bob's going to create his public key, private key, and a summary of each introduction point. He's going to send it up to his directory server up here, and we'll advertise it there. Now, once Bob's done that, once you see the hidden service is set up, your client needs to somehow learn that the hidden service exists. The .onion addresses, they're not, you can't necessarily just Google for them. To some extent you can Google for them, but assuming that's because people have put them out on the regular internet in places where Google can index it. But otherwise there isn't really so much a search engine on Tor for what's all the sites, what can I get to, what's where. You have to learn about the names somehow. So whether it's a chat room or whatever the case is, you talk to your friend, you can Google some. There's a bunch of them on Reddit. It's easy to find. And so you find out that it exists. The client needs to get more information about the server. They don't know what the IP address is, they don't know anything. So they contact the database, this distributed hash system, says, I want to know more about this hidden service, what can you tell me? It will send it the public key of that service so you can encrypt your data when you go to speak to it. And it will send you the introductory points to communicate with that hidden service. From there, the client will set up what's called a rendezvous point. So it will set up its own another 3-step circuit to another random system on Tor, another random node. And it's going to be used as like a middleman to communicate between Alice herself and Bob, the hidden service. From there, the client sets up an introductory message. It's going to contain I forgot to mention, when it sets up the rendezvous point, Alice will create a one-time secret with the rendezvous point that basically tells it, if someone contacts you with this secret, just send the traffic to me. So Alice will take the public key and encrypt that secret or cookie and the rendezvous point address, and we'll send that, and we'll encrypt it with the public key of the server, and we'll send it to the introductory point. One of the 3. It picks one to go to. Alice will pick one to go to. From there, the introductory point forwards it on to Bob, or your hidden service. From there, Bob will take it, decrypt it, get the rendezvous point's IP address, and get the key, that one-time secret. And then it will send a rendezvous message to the rendezvous point with one-time secret, saying, hey, I got this, I'm trying to communicate with someone that's trying to communicate with me. What can you do for me? Assuming the secret is correct, the rendezvous point will let Alice know, hey, there's a good connection, we got someone that's responded with the proper secret. Here you go, you can start communicating with that person, or server, or service, whatever it is. So they start communicating, and this is going to be a set of hops, about 6 of them total. So it's going to be like 6 Tor relays that it's going through, and this is an issue for law enforcement and other police entities. Because there's so many hops along the way, it becomes very difficult to determine who's going to where the servers exist, who the people are that are using them, because there's so many proxies and systems along the way and so much encryption that it's hard to encrypt all the data and see what's going on. And that's how hidden services work. Questions on that? I know it's technical, if you're taking notes, good. Otherwise, the Tor site has all these graphs and some more details. You can also look at the Tor code if you're interested and you want to learn some C. It's a good way. Yes?
So only the 3 introductory points? Well, my question is, only the 3 introductory points know where the physical existence of Bob's server is?
So, the 3 introductory points actually don't know where the physical existence is. They know that they have a Tor circuit between Bob and themselves, and that's about all they know. So they can at least know how to get to Bob from
How's
there.
that again? I missed it.
Because when Bob first sets up his hidden service, he will pick 3 introductory points and basically create the connections and there's it sends special data like. I didn't go into all the technical details, but basically Bob will send a data with the hidden service details, saying if someone tries to contact you on this hidden service address, like one of those .onion addresses.
Go to Henry.Go to Henry.Go to Henry.
Exactly.
Okay.
And along this process, along the circuits, your guard node only knows the IP address of the relay node, and the relay node only knows the IP of the exit, and the exit only knows the IP of whatever the endpoint is.
Right.
So at any given point, any system only really knows 2 IPs. The one that it's talking to, so in the case of the relay, it knows the guard node's IP, and because that's who's talking to him. And then the relay also knows the exit node's IP, because that's inside the message body.
Okay, so the guard doesn't necessarily know that it's talking to an actual server. It could be, for all it knows, another relay.
Yeah,
Okay,
exactly.
cool. Thank you.
Yes.
In terms of privacy protection, what's the difference with a VPN, for example?
So in terms of privacy protection, what's the difference with a VPN? So the VPN, you have encrypted data to a single endpoint. If I'm able to sniff traffic on the internet, I can see that you have a steady connection going to one entity, and from there, there's connections going out. Depending on how many systems are connected, either way, the data is encrypted the whole way through, from your point to the VPN endpoint. And similar in Tor, it's encrypted all the way through to the exit node. So it's basically with VPN, you have like one system in the middle,
And there are three.
and then you have 3 hops. But similarly, you can come out of different IP ranges. So like using Tor, you can come out of wherever there's exit nodes. So you can come out of the US, Russia, Canada, France, Switzerland, whatever. Same thing with the VPN. So, within services, you want to be careful where you're going to. Make sure you know what the site is before you actually visit it. Start using Tor or checking it out. There's a lot of ugly things you can find out on there, and you don't necessarily want to come across some of it. The best way is to check hidden wikis. You can actually just do a Google search hidden wikis, and you'll find them come up pretty quick. It will be a list of those .onion addresses, not all of them that are in existence, but some that people have put on the hidden wikis. The .onion addresses along with what's on the site, what you can find on the site. And there's like an example on hiddenwiki.org. So there's plenty that you can use, but make sure you know what you're connecting to before you go connecting to it. And sometimes you can determine the content of a hidden service based off of the wiki name. Technically, the .onion addresses are supposed to be randomized, but there's a way to kind of change it and get something a bit more readable. So like this one says like Tor wiki blah 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 .onion, and sure enough, it's a Tor wiki page. Questions up to this point? Okay, so who actually uses Tor and why? On average, there's like in 2016, it was like 1.75 million people average were using it per day or per month. Pretty steady amount of traffic overall. Sorry. But then usually, when you actually hear about who uses Tor, you hear about things, or the Darknet, you see things like this. It's all about drugs, money, viruses, all that. And it's very, very, very true. There's a lot of bad uses on Tor. You can find pretty much anything and anything that you want on there. From things that aren't so bad all the way to like the worst of things you can imagine. Which brings up some moral and ethical questions about Tor. But don't judge a net by its cover. Yes?
What is CP?
CP is child pornography. So that's a very common thing that's, for people who are in that's what they use Tor a lot for because it helps them stay private. But there's a lot of activity by police and law enforcement to try and hunt down these sites and the people using them and take them down. Same thing with the drug markets and weapon markets as well, and the credit card fraud, but to a lesser extent.
How did you take that down? Maybe you'll touch on that?
Yeah, touch on it a bit later on. So Tor, given its bad uses, it does have good uses as well. One, for those who want to be a bit more private, you can stay, you can keep your anonymity a bit more if you use it well. You can circumvent all content, so if you're in a country that doesn't let you see the content that you want to see, or visit the websites that you want to visit, you can use Tor similar to VPN to be able to circumvent that. And also freedom of speech. Countries where people live in where they're not allowed to speak out against their governments, and if they do publicly, they'll be, arrested, tortured, and so on. They can use Tor to talk about what's going on in their countries. They can use Tor to access different content, to share what's going on, and it helps them stay safer. I can't say stay safe 100%, but it helps them stay safer. So Tor also has its good uses as well. And the moral and ethical questions, given all of its good and bad uses, just food for thought for later. Should it really be maintained? Should Tor remain legal? Should should Darknets, things like this, remain available to the public? Given the good and bad uses you can use for it. And now we'll get into the weaknesses. How people actually get their anonymity removed. A lot of it's third-party programs. So if you have vulnerabilities in a browser, if, for instance, what's happened before, there was an FBI operation called Operation Torpedo where they targeted a few child pornography sites, and they were able to get hold of the sites themselves and get access onto the sites, on the web servers. And from there they uploaded code that exploited a vulnerability in Flash. So any person who wanted to use the site and had a vulnerable version of Flash, the code executed silently on their systems and forced them to connect out directly to an FBI server with the real IP address outside of Tor. And so that was how they were able to get through and attack and target a lot of people and arrest a lot of people through there. Flash and WebRTC, both of them use direct connections to endpoints sometimes, so those are, if you're using Tor, you want to stay more safe, you want to disable Flash, JavaScript, and some things like that. The other issue sometimes for how people get caught is actually security issues on the hidden services themselves. Has anyone heard of the Silk Road? Yeah. So, Dread Pirate Roberts. FBI says that they were able to get the IP address of the Silk Road server because, what was it? They had an issue with the CAPTCHA system on the server that was leaking the IP address information. Security researchers don't really agree. They think that after some maintenance that they did on the Silk Road site, that it was not configured properly, and the FBI was able to manipulate the $_server variable for PHP on a PHP page to actually send out the IP address and see what it was. Either way, there was bad security on the actual hidden service server itself, and that got that system caught and people using it caught. Other things that issues or browser enumeration or fingerprinting is actually can be a pretty effective technique in identifying people online. Because everyone has different plugins, different version numbers of the plugins that they have installed, different version number of the browser, different languages that they have installed on their system, and all this data is sent through your browser to the servers, and so people can use that to start creating an identity of this person, this browser fingerprint is some person. We don't know who it is, but it's some person. And eventually they can, after enough data or finding that same fingerprint elsewhere, they might be able to identify you. More issues with DNS leakage. As I said, .onion domains are not actually resolvable normally, but if you don't configure your systems correctly, when you go to the .onion sites, you go to the hidden services, you will send your DNS requests out in the clear. DNS is not encrypted, so it's plain text. So someone may not be able to see exactly what you're doing, but they can see what sites you're trying to go to on Tor if you don't have your systems configured correctly and you're leaking your DNS data. And then the other ones are timing network correlation attacks. If you have a sniffer between your system, between the client and the guard node, the entry node, and a sniffer between your exit node and the endpoint, the end destination, with enough time, enough data going through, you can actually get up to like 90–95% accuracy on identifying someone's IP address and who they are, even though they're using Tor. It takes some time, of course, there'll be some luck getting your sniffers in all those places, so on, but it's possible. And the other and last one is nation states or governments or people with enough time and money. Because what happens is the client just gets a list of Tor nodes and selects them randomly. It's not so random. Tor used to be super slow. I shouldn't say super slow. It used to be quite slow. And to fix that, they kept the randomized process of selecting nodes for your circuits, but they have favoritism towards nodes that have higher bandwidth capabilities, better uptime, so that when you're getting nodes that are online that you're able to send your traffic through and you're not just going to be sending traffic, it's not coming back and you don't know what's going on. Because of that, a nation state or someone with enough time and money can set up tons of Tor nodes, enough to become a sizable portion of the total Tor nodes on the network. I think last time I checked there was like 7,000 Tor nodes in existence. And you can create a large enough set of it with a high enough priority, with enough bandwidth, enough uptime, that you can more easily get picked as nodes in people's circuits. And if you get lucky, you might get picked as 2 of them, or even as all 3, or if they're going to a hidden service. If you have enough nodes, you can end up getting lucky and getting picked as all 6, in which case you have end-to-end view of the traffic going through, and it's very easy to identify who's doing what and where they're going. So that's the other weakness. It's debatable on if people are using it or not. There's been some tools out there to identify Tor nodes that are set up the same configurations. They found clusters of like 300 at a time sometimes that are set up the exact same, likely the same owner, same person setting them up. So actually, how to use Tor. Easiest way will be to download the Tor browser and use that because it's basically a package. You run a binary and it's available on Linux, Mac, pretty sure it's available on Mac, available on Windows, and you run it and it just sets everything up for you and goes. Tor itself, the client is just a SOCKS proxy, so basically any proxy-aware application on your system, you can configure if it knows how to talk with a SOCKS 4 or SOCKS 5 proxy. You can point it to your Tor, it's basically like point it to localhost on the port that Tor is listening on, the Tor client, and it can send its data through Tor. If you want to get paranoid, there's this thing called Tails, which is a Linux distribution specifically set up to be used as a live CD. So it's preferable if you do not actually install it. You run it as a live CD. This way, no data is written to your hard drive. Then when you're done, you shut down the system, and when it shuts down, it actually wipes. Even though technically RAM is supposed to be deleted once the power turns off the computer, it will actually wipe the RAM when it shuts down, specifically to get a bit more paranoid, make sure that there is no real way to get to the data. We'll do the underground economy and then I'll go browsing around a bit and show you the Tor browser itself. So, I'm going to take a quick sip of water. Does anyone know what the underground economy is? Has anyone heard of it before? Yeah.
This is like a black economy that's not measured by normal GDP.
To an extent, very much so. It said it's like a black economy that's not measured in terms of normal GDP. And it's true, it's one of those other shabby places you don't go to. But it's an entire economy of goods and services that aren't really dealing with legitimate goods and services. It's usually things that are illegal. But they're not always tied to Tor I2P. You can have underground economies, just essentially like black markets. Yeah. Some of them are actually accessible outside of the Tor network, outside of any of those anonymization networks. Like here's one. I'm not sure how much I would trust it going to it, since you have SSL encryption going to it, but your IP address is open, and so on. It's more of like a newbie network to get into. But it's interesting if you want to go checking around what's on there and see what's available. You can see like some of the posts and stuff. There's usually a lot of scammers on these ones that are available without Tor and so on. But it's interesting to see what's going on. So things you can find: drugs, weapons, hacking services, identity theft, tons of identity theft, tons and tons and tons of identity theft. You can buy credit cards or identities sometimes for as cheap as like $5. They'll sell batches of like 500 cards for like $100 or $200 at a time sometimes. It depends on what the going rate is. Some countries, their credit cards are worth more than credit cards from other countries due to popularity, and also some countries that don't have as good as security services on their credit cards, so if you can get one that works, you can use it more often, you can actually get more out of it. And also some countries are richer, so the people who have the cards have higher limits, you can buy more. So here's an example of one site. If you wanted to go buy Desert Eagle or some firearms, you can. This one is like 1,000 something or 12,000 something euros. If you want to rent a hacker, it's available also. This gentleman in particular is very specific that he wants only serious individuals willing to pay. If you want to become a U.S. citizen, it's also available on there. I also don't know how much I would trust it, for it to actually be legitimate or not, but it's up to you for you to try if you want it.
Does it say that $900 equals 9 Bitcoin?
This was 5,900.
Oh, I'm
Yeah.
sorry.
So, no, sorry. Yeah,
That's
that's
That would have been like,
That's way back. You can also find drugs, narcotics on there, online as well, pretty easily. Delivery is a different process. A lot of times they'll try and find third-party people to pay to deliver packages for them. Like they'll send a package to someone, have them like drop it off at a drop-off point, and they get paid money for it, and it's your job to go pick up the package from the drop-off point.
So you have to get involved another person in the process.
Yeah, usually it's up to the person shipping goods to try and set that up. But people will negotiate on how to deal with the shipments. Another way that people will deal with shipping goods and services is by, instead of, for instance, I steal a credit card, instead of giving you the credit card number and info, what I can do is I can buy some goods and services real quick. I can buy like an iPhone and I can ship it to you. And it'll be a legitimate purpose on Amazon or somewhere, but I can ship it, or you can ship it to like some other address and you can just be out there waiting to pick it up, whatever the case is. And that way you can get the iPhone or whatever it is, and then you can go sell it, and that's how you'll get your money. So that way, instead of you having a credit card and then possibly tracing the credit card back to your ID, you just buy something with it and you get it back. Or sometimes people use the credit cards to buy bitcoins and then use the bitcoins to buy goods, so it's more anonymous, things of that nature. So the better sites, you can find some really well-made sites on the underground market. Like sometimes better than like actual like legitimate sites, because people make tons of money off of it. There's sometimes millions of dollars going through. Like the Silk Road had millions of dollars going through their marketplace. The better ones are invite only, where you need to have someone to vouch for you to get onto the site. Reason being, if I actually want to use the site and I want to stay using it, I'm only going to invite people that I know are going to be good and actually be legitimate. Because if they are bad, then I also get kicked off the site too. There's escrow services for payment. So I want to buy something, I give the third party my money, they'll hold on to it until I receive my goods. I tell them the goods are okay, and then they'll release the money to the seller. They have dispute systems, so I can sit there, I can tell someone, I can buy a pack of credit cards and I can go and dispute and leave a review or comment on this person saying that they're a scammer, and I can tell like the marketplace that I bought 20 credit cards, they gave me one that worked to test, and then after that, all the rest did not work. And they'll go back and forth, you take screenshots, similar to how you would do like a dispute on eBay or PayPal or something, try and get your money back for goods and services that you did not get that were proper. They have the same systems. And some terms, if you start to look into this stuff, carding is just dealing with credit card theft. Fools, spelled in different ways, also credit cards, theft, CVV, CVV2, BINs.
Why do people sell their credit cards? Why don't they just use them themselves?
Because there's risk in using it. So, because then you have to, depending on where you use it, you could possibly get caught or could get traced back to you. So sometimes it's easier just to sell it, safer. And then doxing. Is everyone familiar with doxing? For those of you who are not, it's when someone finds all the personable PII information, all the personable identifiable information about you, and just puts it online. So if I have a grudge against some hacker, someone online, and I can't figure it out, I can probably pay some other hacker to go dox that person for me, so everyone knows who that person is, and it like ruins the reputation. It's supposed to look bad. Social security numbers and stuff, also not good to have out there. Questions before we go on? So,
what's the point into like being a node or making nodes for people to do that?
So, it's more a matter of usually it's for people who either want to contribute to the dark side or the good side, basically. If you like the purpose of it and you want to give people the ability to use it, so contribute.
Don't earn any money of it or just
No money. Yeah, it's see, some people do it for security research. They want to investigate things with malware and so on. They'll use Tor sometimes to set up their own nodes to try and see what traffic is going through the nodes.
For example, if you're an exit node, then the person will access to the website with your IP. And then, like, for example, if the authorities get the IP, they will get yours instead of the people's. So, like, it's risky for you.
It is risky. And it's something that people have to take into consideration if they're going to run nodes. So a lot of people will be relay nodes. They'll choose to only allow their systems to be relay nodes, so they're never the exit node along the way, so they don't have to worry about it so much. But some people really believe in the cause of Tor, whether good or bad, and so they want to have systems up and running as exit nodes.
What's the job of the security researcher in this space?
In the space, a lot of times it's dealing with viruses. A lot of police and law enforcement are going to be dealing with underground economy, going to be dealing with Tor and anonymous services to try, because people are using it for a bad thing, they need to try and capture it.
So it's not only law enforcement, there are like public companies, business, commercial companies that are doing this?
Yeah, sometimes they'll use it to go search, for instance, a bank might want to know, or some service, any place might want to know, has our data been hacked and leaked? If it gets leaked, a lot of times it gets leaked on the Darknet. So there's services out there that have basically open source information gathering, where their job is to go crawl the Darknet all over the place and try and look for leaked data, and then they can tell people, hey, you know, bank A, tons of your credit cards got hacked, maybe someone got into your database.
Is there a way to like shut down Tor or like DDoS it even? There's only 7,000 servers.
Yeah, I mean, theoretically, I guess if you could get enough bandwidth to DDoS all of them, you could. Or perhaps if you could
Like, has that actually happened in the past when people tried to like take it down themselves?
I don't know. I haven't checked it out, so I'm not sure. But it would be interesting to find out somehow, you know. So on Linux, starting the Tor browser is pretty simple. Once it's downloaded on the card, you can just literally start the process and it'll pop up. And I'm hoping it'll pop up on this screen. If we're lucky. Awesome. So I'll do just a few examples. One's going to be simple, just go to Facebook. And I'll show you what the
It's not illegal per se to use Tor, right?
No, it's not illegal in humanity use Tor. Or I2P. It's not illegal by default. It's just a matter of what you do on it. So, the thing that's cool with Tor browser, you can check what your circuit looks like. So I'm hitting, in this case, I'm hitting 3 servers in France. Go figure. And then I'm getting out to the internet, wherever this is, but in this case it's Facebook. And then I can set up another connection. I checked, this one used to be a big popular market, one of the biggest ones out there. It's called the Hansa market. But I checked it out yesterday. It didn't quite work. And hopefully we'll see why.
That's not good.
As you can see, Tor can be a bit slow, especially going to hidden services because of all the hops and directions in the way. It will load up for me, otherwise I took a screenshot and I can show it. But live examples are always hit or miss. In the meantime, we'll see if I can load something else. Let's see. This one's the Wall Street market. It's a more up and coming market. It's a newer one. I'm still hoping we're going to get through. But if not, I'll have to kill Tor and restart it.
So the hops basically can turn this into like the late 90s dial-up.
Yeah, more or less. Depends on, sometimes you can get faster connections, it really depends. But you can see with this connection, I'm going through 2 hops in France, 1 in Czech Republic, so I have my entry node, my guard entry node, my relay, and my exit. There's 3 relays that I don't know about, and then the unknown site that I'm going to, because this one's an actual hidden service. This is why I don't see these 3. I have no idea who they are.
They could be in Asia or something like that.
As far as I know, yeah, it could be just about anywhere. So it seems like I'm not having any luck, so I'll open up the screenshot instead. So it might be hard to read. I apologize. Basically, the Hansa site that I checked that was working when I previously did this talk here, it has since been seized by the FBI and Interpol and a few other police organizations, law enforcement organizations. So it was pretty entertaining to find it yesterday when I was verifying that some of these, making sure that they still work, and then I saw that this one had been seized. It's like it goes well with the talk. Also, there's another one called the Alpha Bay Market. It has the same seized picture up, so it was also taken down in the same operation, two of the markets. So this one's the Wall Street Market. To log in, to actually get to the site, you need to pass your CAPTCHA and everything, but you need an account, and you need a voucher to get in. So I can't register without someone actually giving me an account to get on there. But then, you can see they have their own Reddit, their own subreddit. And as long as this one works, or I'll open up another browser, perhaps, for the sake of speed. Oh, okay, so that works, cool. So, Wall Street Market, so they have their own page for themselves on subreddit, their own Reddit page. Question?
Yeah, what does it mean to seize like a site like that? Did they actually seize the physical server and
Yeah, they actually get access to the physical server and grab
they
it.
just deactivate it from the whole network or just wipe it?
For this case, they probably left it up and running, and then they just changed the website that when it loads, instead of loading the actual site, it loads their seize page on it instead. So they might still be tracking people to see who goes to it, but then again, like without actually using the system, them seeing what you're doing, there's nothing illegal with visiting that site in particular.
Right.
Let's see, what does this one have?
Prescription drugs.
Yes, this one has, it used to be further up on the page yesterday, but they have new vendors selling prescription drugs and things on them. So this is on a subreddit, like an open subreddit that you can go check out on your own. But actual access to the site, it's finally loaded, go figure. But actual access to the site, you can only get through Tor, you can only get through a voucher and so on. But you can find tons of sites like it on there if you want to go digging around. Any questions? Comments? Help with the test? Just kidding, I didn't have a test, so I don't know how it's going to be for you guys. But, so that's it, so, question.
Are these like the frequency of them getting seized increasing with time, or is it just kind of random? Like, is it easier now for government agencies to kind of track down and find where these are and break this?
You know, I'm not entirely sure. I haven't done like an actual measurement to see like how often, but it has felt more often that things are being seized. But then again, there's so many sites and some that they don't even know about, so we can also say that it's really not so often it's being seized. You know, every time, like anything in technology, as soon as people find a way to, hackers find a way to break something, get into something, or create sites, eventually the good guys, whoever, find a way to patch it, or find a way to seize the sites, and then based off of what happened beforehand, the hackers find new ways and better ways. So it's always a cat and mouse game.
Is it easy to create a website on the DOM?
Yeah, it's quite easy because there's a lot of guides on how to do it online. It's just you basically set up the website any way you normally would, and then you have to set up the hidden service. If you run a hidden service, you want to make sure that it's only accessible through your Tor port on your system. You don't want to also have it accessible just if someone hits your IP address on like 80 or 443 and they'll get to it, because then it kind of defeats the purpose of having it as a hidden service. But more and more places are actually starting to run hidden services. Facebook has its own hidden service. The Wall Street Journal, if I'm not mistaken, just started running their own hidden service as well, as like a a thing to see how many users are going to get, how many more readers they'll get, since some people can't access Wall Street Journal in their own country. Then they're opening it up as a hidden service now.
Again, what's the deal with the underground market? Sometimes it's legitimate, so why?
You can find legitimate things on there, legitimate goods and services, but most of the time on there you'll find illegitimate things. Like on the Satna market or like Pirate Bay, I don't know if there was any actual legitimate things because I think most of it was illegitimate, but even if there was any legitimate items on there, all of the illegal stuff just made them take down the site. So we're about at an hour. So if you have any more questions, feel free to come up to me afterwards. I have contact info somewhere, or not. I'll put my contact info up. Feel free to come up to me. You can also see, just write down the contact info if you want to. And yeah, thank you guys so much for staying so late and being with me. Appreciate it.